Welcome students. So in this class we are going to continue with the chemical properties of alcohol, and in this we are going to see the reactions. This is the reaction of alcohol with ammonia. Reaction of alcohol with ammonia. So here, when vapors of alcohol and ammonia are passed over heated alumina, okay, that is aluminium oxide at 633 Kelvin. When vapors of alcohol and ammonia is passed over heated alumina, that is aluminium oxide, that is aluminium oxide, that is Al2O3, at temperature of 633 Kelvin. A mixture of primary, secondary and tertiary amine is produced. Okay, so here we can take example that ethanol reacting with ammonia in the presence of alumina at 633 Kelvin. So here CH3, CH2, NH2 will be formed out. Similarly, when more of the alcohol molecule will react here with the ammonia amines formed here, then the product here it will be CH3, CH2, NH2 twice, NH plus H2O. Then again one more molecule of alcohol will react with the diethylamine. Okay, this is ethylamine. Ethylamine. This will be diethylamine. Then when again one molecule of alcohol will react with the diethylamine, it will form triethylamine. CH3, CH2 thrice N plus H2. This is triethylamine. Okay, so this is the reaction where we are seeing that the carbon and oxygen bond is breaking out here. Okay, and here the breakage of due to breakage of carbon and oxygen bond, here the reactions are taking place. So there are total 4 reactions in this particular, using this particular for phenomena. The next is the reaction of alcohol involving the cleavage of alkyl and hydroxyl group. Okay, alkyl and the hydroxyl group here. That means that the carbon and the OH bond will be breaked out. Okay, so in this the first reaction is acidic dehydration. Acidic dehydration. So when alcohol is heated with a protonic acid such as H2SO4, H3PO4, at 443 Kelvin. Then the formation of alkene and water will take place. Then dehydration occurs, then dehydrated to form alkenes. Okay, alkenes will be formed out. So here C H C OH. So here H plus heat will be released out. Formation of C double bond C, which is an alkene, plus H2O will be taken place. So here we can take one example. The example can be, I am taking here the example of ethanol. Ethanol. Okay. So ethanol on dehydration, okay, undergoing dehydration at 443 Kelvin in the presence of any acid, okay, then it will form alkene, that is ethene, C double bond C, H, H, H and water will be released out. So ethanol has converted to ethene here. Next, propane one all is there, CS3, CH, H, COH, H and H on using a protonic acid at 443 Kelvin. The formation of propane 1-ene, prop 1-ene will be there. Prop 1-ene will be here. Propene. Okay, so from propane to all, propane to all, propane 1 all, not 2 all, propane 1 all, prop 1-ene will be formed out. Secondary and tertiary alcohols dehydrate to form under mild condition. Okay, they dehydrate under mild condition. So CS3, CH, CS3OH, that is secondary alcohol. There 85% concentrated H2SO4 will be required, and at 440 Kelvin temperature it will dehydrate to form propene. Okay, it will dehydrate to form the propene here. H2. Similarly, C, CS3, CS3, CS3OH. Here, for tertiary alcohol, for dehydration of tertiary alcohol, 20% H2SO4 solution will be required at 358 Kelvin temperature to form 2-methyl propene. Okay, 2-methyl propene. 2-methyl propene plus water. Okay, so this is the reaction of the, or the conversion of dehydration of alcohol from alcohol to alkene. Okay, so here we can see that the tertiary alcohols are easily dehydrating as comparison to that of the secondary alcohols, and secondary alcohols are easily dehydrating as comparison to that of the primary alcohols. So the reactiveness here is more in case of the tertiary alcohols as comparison to that of the secondary, and it is more in case of the secondary than the primary. So what is the reaction here? So the reaction mechanism involves here that the alcohols here, which are present combines with the protons of the protonated acid. Okay, it will combine with the protons of the acid to form protonated alcohol. Okay, it will form a protonated alcohol. H2O. Sorry, here it will be one oxygen combined with two hydrogen with a positive charge. One hydrogen here, and a positive charge on oxygen. Okay, this is protonated alcohol, also called as ethyl oxonium ion. Now, here what will happen? Here the cleavage of the bond will take place because carbon is also having positive charge and oxygen is also attaining the positive charge. Due to this reason, the repulsion between these two atoms will increase and the water will be released out from here. Okay, in the next step, we will see that the releasing of the water will take place, which is a slow process. Okay, which is a slow process here, and the formation of carbocation will take place. Okay, and due to the breaking of this bond, the formation of carbocation will take place here with water. Now, elimination of a proton from alkene. Here this hydrogen atom, okay, this hydrogen atom, it will be eliminated. Okay, it will be eliminated from here to the to form a alkene here. Okay, from this carbon atom, in order to make this atom, this compound stable, this hydrogen will also be eliminated here. Okay, and after elimination of proton minus H plus ion, here the compound will form, it will be C double bond C H H H and H. Okay, so this is the formation of, this is the mechanism which is involved here in the dehydration of the alcohol. Next is the oxidation reaction. Oxidation of alcohol. Of alcohol. So the oxidation of alcohol involves the formation of carbon-oxygen double bond with the cleavage on an OH and CH bond. Okay. Here the cleavage of OH bond and a CH bond will be occurred out here. So here CH and this is OH. So the breaking of the bond here, it will be here and here, bond breaking. At these two particular points, the bond breaking will occur, and due to this reason, the formation of carbonyl compound will take place. Okay, and this reaction is termed as dehydrogenation. Dehydrogenation reaction. Dehydrogenation reaction. Here, for the primary alcohol, the reaction will be RCH2OH and on oxidation of alcohol here, of the primary alcohol, what will happen here? The formation of C double bond O H, that is the aldehyde, will be formed out here. And on the further oxidation of aldehyde, carboxylic acid will be formed out here. Okay, so here if I am using a strong oxidizing agent, if strong oxidizing agent is being used, then the alcohols will convert to, on oxidation, it will convert from alcohols to aldehyde. Then on further oxidation, it will get converted to the carboxylic acid here. Okay, so oxidation in the presence of K2Cr2O7, which is one of the good oxidizing agent. Okay, potassium dichromate, it is one of the good oxidizing agent with dilute sulfuric acid. Then the reaction, it will be occurred out here, it will form acid aldehyde. Okay, CH3CHO, that is methanol. Okay, Next, when further oxidation will take place, okay, further oxidation will take place because here K2Cr2 is a strong oxidizing agent, so the reaction will complete out here to form CS3C double OH, that is carboxylic acid. Here it is acetic acid, acetic acid. Okay, so here we are observing that the same number of carbon atom is present. Okay, the number of carbon atom when we are using primary alcohol and oxidizing it, then the same number of carbon atom is present when we are forming aldehyde or when we are forming acetic acid. Next, in the case of secondary alcohol, let's observe for the case of secondary alcohol. So in the case of secondary alcohol, CS3C, OH, H, which is isopropyl alcohol, there, on oxidation of isopropyl alcohol, acetone will be formed out here. Acetone is formed out here. And on further oxidation here, in very drastic condition, okay, in very drastic condition, if the further oxidation is taken place for acetone, because generally acetone does not oxidize further, okay, ketones does not oxidize further. In very drastic condition, they can be oxidized out. Drastic condition, they can be oxidized out to form acetic acid or with water and carbon dioxide. Generally, chromic anhydride can be used to oxidize the acetones. Similarly, for the tertiary alcohol, if I am taking an example for the tertiary alcohols oxidation, then here CS3, CCS3, CS3, OH. So here also in the tertiary alcohol case also, the oxidation is very difficult here. Okay, the oxidation for the tertiary alcohol is also very difficult because they do not have hydrogen ion there. Okay, they are having only alkyl groups there. So the alkyl groups just denies the oxidation process there. But when they are treated with acidic oxidizing agents, strong oxidizing agents such as potassium dichromate or potassium dichromate or KMNO4, okay, that is potassium permanganate, in the presence of acid, okay, under the acidic solution of their very strong condition, they will at very high temperature also, okay, at elevated temperature also, the cleavage of the carbon carbon bond will take place for the oxidation process. Okay, so here also we will see that on drastic condition, under strong condition and using of very strong oxidizing agents such as KMNO4 or K2Cr2O7, we will form acetone. The number of carbon atom has been decreased out here. Okay, and then again under very strong condition, the ketones can be then converted into carboxylic acid. Okay, oxidation of the carboxylic acid can be done to form acetic acid with carbon dioxide and water. Okay, next is the dehydrogenation of alcohol. Dehydrogenation of alcohol. So the dehydrogenation of alcohol achieved when the vapors of alcohols are passed over heated copper at 573 Kelvin. Generally, the primary and secondary alcohols get easily dehydrogenated from alcohols and ketones respectively, okay, to form alcohols and ketones, while tertiary alcohols get dehydrated under the reaction conditions to alkenes. They does not form the ketones or aldehydes, they form alkenes there. So in the case of primary alcohols, the dehydrogenation reaction will be taken place when here the vapors of alcohol is passed over heated copper atom at 573 Kelvin temperature. So the formation of water will take place from the alcohol atom, and CS3 C double band O. Okay, here, sorry, not water, it will be the formation of H2 will be take place here. Okay, O will be here and H will be reacting with the another H which is present here in the carbon, okay, in the alcohol group only, and the formation of aldehyde will take place here with the removal of hydrogen, dihydrogen. For the secondary alcohol also, for the secondary alcohol also, the dehydrogenation process will take place. CS3, CS3, OH and H. So here also removal of hydrogen will take place when vapors of the alcohol is passed over the heated copper at 573 Kelvin temperature. Then acetone will be formed out here. Acetone will be formed out here with the removal of dihydrogen. Okay, so here aldehyde is been formed out in the case of primary alcohol. Then ketone is been formed out in the case of secondary alcohol. But in the case of tertiary alcohol, dehydration can be occurred out to form alkenes. Here alkenes will be formed out. Okay, here not aldehyde, not alcohol. Here the formation of alkene will take place. Cu at 573 Kelvin. The same will be there. Vapors of tertiary alcohol will be passed over heated copper at 573 degrees Celsius. So formation of alkene will take place with the removal of water. Okay. So these were the chemical reactions for the alcohols. In the next class, we are going to see the chemical reactions for the phenols. So for today, I am closing the class here only. We will meet in the next class. Thank you.